everyone. Welcome to the 10th session of Electromagnetic Theory and Interference course. In this session, we will find the electric field intensity due to a point charge and we will be doing a problem based on that. So let us understand what is electric field intensity. So it is nothing but the force experienced by the unit point charge when it is placed in the electric field. So E is nothing but F by Q. So the direction of E vector will be in the direction of force. Both will be in same direction. And how can I measure this electric field intensity in terms of Newton per Coulomb? Okay. Or I can write the other unit like volts per meter. The validation for this unit we will be discussing in the upcoming sessions. So to find the electric field intensity at a point R, due to a point charge located at R dash distance, how can I write? It is nothing but Q divided by 4 pi epsilon naught R square into AR cap, because we know the force relation, right? In that, one of the charge at the numerator get cancelled and we get only one charge at the numerator, right? At the point charge we are finding. Now we are going to replace this unit vector by vector divided by magnitude. So already one magnitude square is there. Combining with that, we get a cube there. R minus R dash vector divided by magnitude of that vector, the whole cube. So if I take the point charge which is located at, if I want to find the electric field intensity at a point R, okay, but my point charge is located at origin means then this r dash turns out to be 0. Then how will I write the formula? It is q divided by 4 pi epsilon naught r square into ar cap. Now if there are n number of charges q1, q2, etc. q1 and they are located at r1, r2 and rn vector, the electric field intensity I can find by summing the electric field intensity due to these individual point charges. So it is following the superposition principle. So what is common here? 1 by 4 pi epsilon naught will be common. Here the charges will be varying for each electric field and the position vector changes. So I can write generally, so qk into r minus r1, this is for the first charge, and this second charge is located at r2, right? So r minus r2. We are aiming to find the electric field intensity at point r. Okay. So how will I write? qk r minus rk divided by the magnitude of that whole cube. And the summation, how should I take? K varies from 1 and it ends at nth charge. So 1 to n. This is the formula, right?
Now let us apply the Coulomb's law that we have seen in the previous slide and find the electric force that is acting on a charge due to the presence of two charges. So here in the question, 2 point charges, there is 1 millicoulomb and minus 2 millicoulomb are given and they are located at the particular location. So we are supposed to find the electric force on the test charge, that is 10 nanocoulomb. Okay, q is equal to 10 nanocoulomb, which is located at r vector, that is equal to 031. We have to find the electric field intensity also. So we already know from superposition theorem that is applied on the Coulomb's law when there are more than 2 point charges. So I can take that force as q divided by 4 pi epsilon naught. The test charge remains same, right? So this is taken out. What is the leftover? I have to multiply the force due to each charges on this test charge. So q k, so k varies from 1 to 2, and the vector also r minus rk vector divided by r minus rk vector, the whole cube. So now I am going to substitute the value of q here. Q is nothing but 10 nanocoulomb, 10 into 10 power minus 9, whereas 1 by 4 pi epsilon naught we already know it is approximately equal to 9 into 10 power 9. Now I am going to substitute the value of q1, that is 1 millicoulomb, 1 into 10 power minus 3. R is 031 minus R1 first. So that is 32 minus 1 divided by the magnitude of the same vector whole cube. Plus I am going to write the second charge, that is minus 2 into 10 power minus 3 coulomb into R minus, R value is this, minus R2 is minus 1 4, and I have to divide it by the same vector, the magnitude cube. Now let us do the simplification. See here, so what I did is I just subtracted each of the coordinates. So 0 minus 3 is minus 3, 3 minus 2 is 1, 1 minus of minus 1 is 2. So the answer is minus 3, 1, 2. And I have to take the magnitude cube, right? Magnitude means square root of the whatever vector we have found in the above. I have to write as a square term, sum of the squares. So minus 3 square is 9, 1 square is 1, 2 square is 4. Similarly, why the negative sign comes here in the summation? Because I have plus into minus is going to be minus, right? So I am writing it is 2 into, because this is for a second charge, 2 into, same I am doing for the next difference. I am doing the difference of two vectors. So I will get, what is answer? 0 minus of minus 1 is 1, 3 minus of minus 1 is 3 plus 1, 4, 1 3 1 4, and here 1 minus of 4 is minus 3, 1 4 minus 3 will come. If I write the magnitude, I should write like this: 1 plus 4 square is 16, minus 3 the whole square is 9. All things I should make a cube, right? So if I write the answer, it will come 14 cube, root of 14 the whole cube. How can I simplify it? This root is 1 by 2, right? 1 by 2 whole cube is 3 by 2. So what is the meaning? I am splitting, okay? 3 by 2, how can I write? It is 1 plus 1 by 2. So 1 means I am writing the 14 as it is. 1 by 2 is, it's a root. So 14 root 14 I have written. Similarly for the next term. So what I have to do, I have to multiply inside, then I have to find the coordinates. Okay, this is one set of coordinates and these are the other. If I cross multiply, I will get this. So I am taking milli as common out because 10 power minus 3 is there. So the force we have got, so the coordinates I have to convert into a vector equation in Cartesian form. So I have to write all the unit vectors. So minus 5 here, minus 1, so around minus 6 will come here. 1.7 minus 5.4, I will get less than that. So 3.4 minus of minus 4, I'll get 7 plus. Okay, milli, what is the unit of force? It is Newton. So the final thing is I want to find the electric field intensity. So it is nothing but force divided by the test charge. Force equation we have got in the previous step. Now I am dividing with the test charge 10 nanocoulomb. So what will be my result? So I will get the electric field intensity in terms of kilovolt per meter. So I just made the substitution. See it in the 10 into 10 power minus 9. Here in the numerator I will get 10 power minus 3, and reducing the expression I will get the answer like this. Thank you everyone. We will soon meet in the next session.